So in this video, we're going to continue talking about verifying our trigonometric identities. And we've previously stated that one of the approaches that we want to take is let's try to turn a more difficult or complicated side into the easier side. So we're going to approach this problem two different ways. The first time we're going to do it, we're going to take the left-hand side and turn it into the right, because maybe I feel like the left-hand side is more complicated. So we're going to work in that direction first. So I'm going to see if I can separate tan squared over secant squared into something like this, 1 plus or minus cosine u. Okay, so I have to start thinking tan squared and secant squared. That is a relationship given by the Pythagorean identity. So I can rewrite tan squared as secant squared u minus 1 all over secant squared u. Now, if I have a numerator like this over a single denominator, then I can separate this out into two separate fractions so that it looks like secant squared u over secant squared u minus 1 over secant squared u. And moving from here, I see secant squared u is 1 minus 1 over secant squared u. The reciprocal identity tells me that this is cosine squared u. And then this would then factor into 1 plus cosine u, 1 minus cosine u, which is indeed what I wanted to try to show. Okay, so that's if I started from the left and turned it into the right. Well, what if instead of that, what if I started on the right and turned it into the left? Okay, let's approach it that way. Maybe I look at this and I say, what if I FOIL these two terms together? I get 1 minus cosine squared u. Okay, I'm thinking that I might want to use a Pythagorean identity here. So if I did that, I would end up with 1 minus cosine squared u is sine squared u. And, now I've got to try to turn sine into tangent and secant. And I don't know, I can't relate sine to secant very well, so maybe I don't want to do that right off the bat. So I'm going to get rid of sine squared u, and I'm going to say, okay, here I still have 1 minus cosine squared u. What else could I do in that case? Well, if I know that I have to ultimately get secant in the denominator, I need to start to realize that, okay, cosine and secant are related by their reciprocal identity. So what if I took this and rewrote that as secant squared over secant squared, because that's 1, minus 1 over secant squared. Now I can, since my denominator is the same, I can rewrite this as a single fraction, so it looks like secant squared u minus 1 all over secant squared u. And remember, go back and look at what I'm trying to turn this into. Now I need to get this numerator into tan squared, and I can do that because secant squared u minus 1 using the Pythagorean identity is tan squared u all over secant squared u. Okay, so two different approaches to the exact same identity, or verifying this identity. One moves from the left, turning it to the right, and the other moves from the right, turning it into the left. So you can see, I hope, that maybe it doesn't matter which side. Go with what you're able to figure out. Look at the puzzle in your own way and see how you would solve that. All right, the last example we're going to look at is this right here. So again, I wanted to show you in the previous example that there's more than one way to approach a problem. I also wanted to show you that you can take a fraction and separate it out, or you can take two fractions and write it together. So those are some approaches that maybe you want to use. In this problem right here, the left-hand side and the right-hand side both look, I don't know, they look about the same. They both look difficult. So what do? Well, just to be, I don't know, difficult, I guess, or contrary, let's go from the right-hand side and turn it into the left-hand side, just to be different. So if that's the case, I'm going to work on this right-hand side, try to turn it into this over here. when I'm looking at this, I need to think, how can I do this? I have two terms in the denominator, both secant and tangent. Those are related through the Pythagorean identity. Remember, the Pythagorean identity says tan squared theta, tan squared x in this case, plus 1 is equal to secant squared x. So they're close, but this, or in other words, this denominator is kind of like my identity, except everything in here is squared. So what if I take this and I multiply by the conjugate, and I end up with, let's say, secant x plus tan x, secant x plus tan x. Okay, so the numerator, I'm going to go ahead and distribute this, becomes cosecant x secant x plus cosecant x tan x all over. When I multiply these two terms together, I end up with secant squared x minus tan squared x. Okay, so far so good. Now how are those related? If I were to subtract this from one side to the other, or let's say subtract tan squared to the right over here, that's equal to 1. So right off the bat, I can get rid of my denominator, turn that into 1. So that leaves me this numerator right here, cosecant, and just so we can see this a little clearer, secant x plus cosecant tan x. Go back and look, what am I trying to get to? What's the goal here? I need a secant and a tangent here in the numerator. Well, I happen to have a secant and a tangent already in my problem over here, so what am I going to do with my cosecants? Cosecant is 1 over sine times secant x plus 1 over sine times tan x. Okay, well now that becomes secant x over sine x plus tan x over sine x, and again I can take this fraction and rewrite it as a with a single denominator, and I end up with secant x plus tan x all over sine x, which is what I was trying to show in the first place. So here is a strategy where we actually multiplied by the conjugate to start us off. The same process would have worked if I moved from the left to the right. I could have multiplied this fraction over here by its conjugate and worked in a similar manner, and maybe you want to try that just to prove to yourself that it does work. So let's kind of review some of these